Hello everyone, here's our CSCI 340 database, and today's chapter we will talk about the logical database design. In a previous lectures and then the chapters we did cover about was the DMMS and talk about some like relations. Okay, that means the tables. Okay, and how can we really like move one more step forward? How can we start to design our database? So of course we need to start with the logical design, and then of course the relation database. How can we convert those ER diagrams into exactly the real relational database like tables? Okay, and we will talk about what's the data normalization. Okay, we talk about like first normal form, second normal form, and then the third normal form. So we're going to cover, and then how can we test the tables for like irregularities, like using the data normalization process. So like this. And when we talk about logical database design, so it's the process, okay, of design how to arrange the attributes of the entities in the business environment, okay, into a really actual database structures, such as the tables of a relational database. Okay, so here's the mainly focus we're going to do. And our goal is to create well-structured tables. Okay, so those like related attributes going to put their own relation to tables. Okay, so how can we properly reflect the company's business environment? And start in the beginning, like for the step one, we draw the ER diagram, right? So after we do the ER diagram, then we need to convert those diagrams into actual relational tables. And of course, we need to apply the data normalization techniques, okay? Compared to Excel, we put like multiple contents like in one cell, but we are not going to do that, okay? Also, we have the like only put like direct relationship data, okay, together. And when we use of the data normalization techniques to test a table resulting the ER diagrams like conversions. So it's a design of it. So you need to remember. First, we try to convert each like entity to a table. So when we join, if you see the assignment, or later if I just like give you the situation there, how can you pick up the entities and then convert it to a table? Okay, so let's say we have the customer. Okay, that means we need to create a customer table. Okay, and if we have the product, okay, so we need to have a products table, all this, and also each many-to-many relationship. So we need to create the associative entity. Sometimes we saw call it transaction table. Okay, that means that we always convert the many-to-many relationship to one-to-many. Okay, that means we involve like three tables. Okay, and then during the conversions, the certain rules must be followed. Okay, here so we talk about rules to ensure that like the foreign keys like they appear in proper place in the table. So we need to know. So right here, when we in the beginning, I just telling you using the ER diagram, and then if we need to showing a complete table, we will join in this format. Okay, so first we do have a table, and then the first row we're putting the PK, then it's the primary key, and showing which attribute. Okay, so it's the primary key. And of course, we do have other attributes, including name or commission percentage, yield for high. Okay, right here. Here's the format, so it would be equivalent. So we'll be saying like primary key, the first column, and then the second column name, okay, commission percentage, and then the year of high. So this one is representing the salesperson. Okay, so here it will be the table symbol containing the attributes were specific. In this called the entity box. Okay, and then the salesperson number we're going to underline. So to indicate that it's a unique identifier, right? Identity of this like entity. So it also is the primary key of the table. Okay, so here's the step. And then we going to like convert the entities in the binary relationship. Let's say we have a one-to-one. Okay, so there are three options like for design table to represent this data. Okay, and when we replace the EL diagram, okay, sometimes like when we given a relationship of all the tables in the database, and we will doing these tables. And if you remember when I talk about the EL diagram in the lab, okay, so we just need to pick one works. Okay, let's say works right here. Okay, so we put a diamond in the middle, and for the cardinality and modality, okay, so you can just using a square bracket and showing what's the minimum and then what's the maximum. So right here. So if we are looking at this side like salesperson, so the cardinality will be like there should be one, okay, and one, okay. So there's a like at least one office and maximum is one office. So it's like 1 to 1, and then right here if the office, so we see if there's a office there must okay at least okay should be have a one salesperson, okay, maximum, or maybe no, then no. And we can tell it's a kind of like one-to-one relationship. Depends on the description or background we are given. Okay, sometimes when you're drawing, and sometimes you can give a correct assumption. It's okay. So because for the database design, sometimes we cannot like cover all the different situations. Okay. And then we have some like option ones. So we have two entities, so combined into one relational tables. So let's say we're putting them together, but because when we say it's the one-to-one, and or the second relation, so we just say separate table for the salesperson and office. So we're going to have two. Okay, and then we're putting the office number as a foreign key in the salesperson table. Okay, because we're office and then we assign right here. And when we design, when we see what's the cardinality and modality, so here can tell um, for the office, maybe when you change, but we're going to assign it so to the salesperson. So we're going to put the foreign key, okay, of the office right here. But if they, how about putting the salesperson in the office this side? Is it possible? So here's the situation like we can think about that. And then also we have the option 3 right here, as we say, like if we separate it, but this time the salesperson number we're going to put it as a foreign key in the office. So option 2 and 3, just like we have a separate tables, okay, two tables, but we're going to like putting the foreign key, okay, in different table. Then it can be both that are possible. So depends on how you're going to design, or like you given a good explanation why you're going to design is okay. And then the next one is like how can we convert the binary relationship like from the one to many relation. So right here we have the salesperson and customers, right? And as the same, you don't have to like follow the the diagram like in this way. We can put a diamond in the middle, put cells, okay, and then putting the cut LD. So there should be at least like one salesperson and maximum one salesperson. So because this one is the one to many relationship. And then the next one is like, okay, they're probably like no sales customer. Okay, the sales like serve the customer, okay, or they can serve many customers. So right here, so will be like 0 and M. Okay, this you can put. And the unique identifier of this entity is like one side of the one-to-many relationship. So paste it as a like foreign key. So this one in the table that represent the entity on the many side. Just remember on the many, so we will putting the foreign key right here. So because like we are impossible to put in the customer, the many tables are in the sales person, this is foreign key. So you should remember the many side we will put the foreign key. So the sales number attribute should place in the customer table as a foreign key. Just like remember this part. And when we really converting it here, just like we put in the salesperson, so we don't have like say show mail options, right? And because we should have separate tables, okay. And so far, when we talk about the many-to-many relationship, okay, right here, the ER diagram, sometimes like when we talk about the drawing the ER diagram, we don't have to like adding the transaction table. So here's the huge main difference. Okay, so if we put the entirety, so salesperson, and entirety product. Okay, so we put sales right here, right, and put the cardinality. So one and many, and then one and many right here. Sometimes if we don't have to put the we call the transaction data right here, interception data, we don't have to. Okay, it doesn't matter. Like in the ER diagram. But when we need to draw the tables, okay, then we need to add the transaction or the one middle table. So we break down many to many relationship tables to one to many. Okay, so at least we will involve like 3 tables: salesperson and products, and then we add one more sales right here. So we add the word like, let's say sold. Okay, sold right here. Okay, so you will see will be the like the salesperson can sell at least one or many sales, or the sales should be like sell by one and only one salesperson. Okay, and then the sales those products, okay, so also belongs to one product, right? At least one. And but for the products, they can like show by so many cells, so at least one. So will be right here. Sometimes when you draw the tables, you need to put in 2 sentences. One is like from the salesperson right here. If I ask like please describe the relationship, okay, between these 2 tables, or like what's the relationship, so you say like one to many, one to one, many to many, and then you need to say, okay, so salesperson sells like at least one and many like products like this, and products and also like sold by the salesperson at least one or many like this. Okay, so this is a description, and there's an idea. And when we convert, so because when we draw the ER diagram, so we with like 2 entities, right? So in the many-to-many relationship, but when we actually in the implementation, then we need to convert them to 3 relational tables. Okay, so each of 2 entities convert to a table with their own attributes, but no foreign keys. Okay, so regarding this relationship, in addition, there must be a third many-to-many table for the many-to-many relationship. So we break it down like this way. So it's like one to many and one to many. Okay, but we say when we say it's a one to many relationship, we have 2 right here. So it's one to many and one to many like this. And then we have the primary key, salesperson, primary key of product numbers. And you are welcome to giving a new primary key, like instead of like combining them. Okay, so we can give a let's say call the sales ID, and then assign is a primary key. Is a good habit like to assign this. Okay, and next, when we converting those entities in binary relationship, many just you can see right here. So it's actual implementation. So it's a combination of like unique identifier of the 2 entities. Okay, so there are many to many relationship, and also we will add the additional attribute. So here is the quantities we call it as an intersection data. Okay, and if we do have a called the unary relationship, if you remember. So it's a unary, and then it's a one-to-one relationship. Okay, so if we are only one entity type involved like one-to-one relationship, then we need to like require at least 1 table, and then maybe we will say that backup. Okay, maybe certain like backup. Maybe we say it's a manager wherever. So we will put in one more right here. Okay, so the foreign key is pointing to the same table as primary key. Okay, so just remember this one. And also we say talk about the manager right here. Okay, so the salesperson. So we can see reading it. So if you look at this part, then you may interpret wrong or like mix up. So you need to be careful. So what's the correct situation? So let's say there are many salesperson reports to one manager, right? Okay, and then one manager manage many employees. Okay, salesperson. So this is a make sense condition, but you cannot like interpret it and that way say one salesperson report to many managers. Okay, so it seems like not that accurate in the business model, and that's how it looks like. Let's say if we have the unary relationship, and then if we have the many to many. Okay, let's say if we have the many to many, because they sometimes for the products they can be the parts of another product. Okay, or sometimes we have the components. Okay, so if we have this, then we need to require like 2 tables in the conversion. Okay, so we need to add the conversion table right here, and that product table we do not need the foreign key. Okay, so we're adding the one is called the components right here. Okay, we change it and we'll put the like the product numbers, and then maybe there's a assembly number will be another product numbers, and then what's the quantity right here. Okay, so it can show the components. So this part is pretty tricky. So when you decide, but I prefer like if you do have some practical questions, then it will be better to help you to understand the design. Okay, and then right here, the second table, we see that is create since the conversion of a many-to-many relationship of any degree. Like let's say if we have the unary, binary, or electronary, so the numbers of table will be equal to the number of entity types. Okay, if we have one or two or three respectively, so it doesn't matter. Okay, and plus like one more table for the many-to-many relationship. Just like remember this part, right? So many-to-many, when we mention like two entities, then we need to add one more. Okay, in the middle, sometimes I call it the transaction tables. So it can help us to convert it to one-to-many. Okay, and once we try to converting the entity, let's say with a ternary relationship, because we have like three right here, four. Okay, and then the primary key of the sales table right here. So it is a combination of the unique identifier of three other entities. Okay, so will be sales numbers, okay, salesperson number, customer numbers, and product numbers. So it combines as the sales right here, right? And of course, when you design your sales table right here, you don't have to really combine three of them together. I always recommend you can like putting and adding one attribute. It's called the sales ID, and it says it's a primary key. So it's a better way to do it than we can do indexing. So it's more like practical. Okay. And then just like giving a really summarize. Okay, when we putting all these, if I give a question, let's say I give you the format in this way, then asking you to draw the complete, okay, the diagram, like the database diagram, then it should be doing in this format. Okay, it should be extended. You can add in the diamond number here, diamond, and then add the cardinality and modality, okay, table right here. Okay, so if I saying is the database diagram right here, okay, or sometimes we say the UML diagram. And if I only say it's the entity and relational diagram, then you can draw a rectangle and that's it, and put the name. So you don't do in this format. So just be careful, okay? And later you will have more like exercise. Also, this assignment asking you draw it, okay? And another one, so showing right here, we try to put all the tables right here, convert to a complete diagram. Okay, so sometimes when we classify, then you need to look at these tables like publisher and authors right here and books. So you need to check their primary key, okay, and sometimes their foreign key. So let's say we have a book and publisher, right? So books and publisher right here. And then you need to think, okay, so for the publisher, what's the minimum? Okay, at least. Can they like publish any book? 0 or 1. Okay, it can be like no books published, right? We can put 0. Okay, so can we publish like only one or many? If it's more than one, okay, that means many. Okay, and how about books? So does it only published by one publisher? Should be right. So one. Is it possible? No, no publisher publishable. No way, so it should be like 1-1. Okay, so it's a one-to-many relation. So here's a situation right here. Okay, and or some other situation about like the music World Music Association database, and sometimes you will see the foreign key or the we're using the double underline, or sometimes we're using dot line. Okay, so either way is okay, just showing the difference. But for the primary key should be okay, should be the one. Okay, just be careful. So then underline, and always recommend using an ID, a number instead of the name, so it would be better. Okay, also it's like for the indexing. So it's like practical. And just one more example right here. So it's the lucky renter car. Okay, so database. So you see all these like example, and hopefully later when you doing the assignment, you have a better idea. So of course right now you just need to draw the ER diagram, the simple diagram. Okay, so you don't have to compute all the details. Okay, and then we talk about the data normalization in this part because this is the methodology for organizing the attributes like into tables so that the redundancy among the non-key attributes like eliminated. Okay, and also the output of data normalization process is a properly like structured relational database. So here's the idea. So you need to have a concept like called concept what is the data normalization. So for the input, so all the attributes must be like incorporated into database. Okay, when we drawing the ER diagrams, okay, the UML, okay, that can be database. Okay, so we all these like attributes and also the table. Sometimes we draw in this way. Okay, at least they should put even later in the project, you also need to showing it. Okay, drawing no matter is the diagram or the table like listing in this way, you have to put it. Okay. And so we will give a list of all the defining association between the attributes. So including functional dependency. Okay, so later you will know it's a functional dependency. Okay, dependency. And then it means that, okay, so expressing that the value of one particular attribute that associate with a single specific value of another attribute. Okay, so if we know that like one of these attributes has a particular value, then other attribute must have the same other value too. It more makes sense if we putting like for the functional dependency with me knowing okay for the information or data for customer. Okay, suppose if we have the DOB address, okay, maybe the phone number, emails, okay, all these therefore directly dependency. Okay, but for the salesperson, sometimes when we decide, okay, so if they have like the office, okay, and then the office location, headquarters, just so they come like independent, then we're not going to like put them together. So we need to do the um we need to have a separate table. So here is showing what's the functional dependence. So for the sales number, should have a direct like dependence related to the sales name, right? Sales that we say. So right here is the determinant right here. So the value of the salesperson number, so again that determines the value of the salesperson name. Okay, so here is the function name really like dependent on the sales number. Okay. So here you need to be careful. So it's like when we talk about the one of the data normalization. So all this then is called a functional dependence. Sometimes we're using the arrow right here to representing. So we're drawing, okay, so what's the numbers? So will be the salesperson name, commission, okay, year file, maybe departments, okay, manager names, okay. And when we talk about like product numbers, okay, right here. So like maybe a product number will be like maybe direct functional dependence to the product name, okay, unit price, okay, and then how about the department number will be the manager name, okay, or like sales numbers, and then product number will be the quantity right here. So if I give all the attribute right here, then you should able to like pick up. So which one most of the time will be the primary key. So you need to able to like find the primary key right here. Let's say sales person number, department numbers. Okay, maybe the product numbers right here. So and then of course she's slightly a tricky one. So you would tell okay because we have the quantity. So if you know the tables design, so we have the salesperson number and product number. So because this one is the intersection data, right? Is a quantity. So it's a like the many to many relationship table, and then we try to create one more tables, right? So will be 2 plus 1, so 3 tables. So the one, the middle one, okay. And you need to showing what's the function and the like dependence right here. Okay, you need to able to draw it. And the steps we I talk about that actually we have like 3 normal forms, like first, second, and third normal forms. Okay, so right here, once the attributes they are arranged in the third normal form, then the group of tables they are like comprised as well structure, relational database, and with no data redundancy. Okay, so suppose that after you compare all this, and then a group of table they say to be like in a particular normal form. Okay, if every table in the group so is in that normal form, we can talk about that. Then the data normalization process is progressive, you know. So if a group of table they're in second normal form, then it's also like in the first normal form. Okay, so it's can be so once you finish like the third normal form, then it should be like in the first or second normal form. Okay, so it will be done. So right here, if I tell you, okay, what's the normalized data right here? We have the sales numbers, and then we have the products number, and then name, all these, right? So all these we call the multi-values attributes. Okay, so if we see the record one row, we put in the product numbers right here, and then what's the product names. Okay, when we grouping all together. So when we do the first normal form, so the attributes under the consideration have been like listed in the one table. So, and this one primary key cell has been established. Okay, so make sure the numbers of record has been increased so that every attribute or every record has just like one value. Be careful, just like I say, one value. So multi-value attribute has been like eliminated. Okay, so we try to remove all these like multi-value. So it will be the first normal form. We make sure each row, each cell only contains one value. Is invaded like you're doing like we're putting like three product number in one row. Okay, so the first step is the first normal form. We move it so we can break down into in this way. So you see sales number when I product numbers. So they write out each row and then the cell right here. Okay, so it only contains one value. So then we will finish the first normal form. So it's like merely like starting point in the normalization process. This is our first normal form. Okay, so it connects really like great deal of like data redundancy because like three workers involved in self-present 137, right? So if we have three pages in which like the name is listed as like Baker and then his commission is listed as 10 and so on. So kind of redundancy occur because it keep duplicated. So also right here, let's say the two worker in for the products like 19440 right here, and then this product also lists like twice as a hammer, and then unit price is at least twice as like 17.50. Okay, right here. So you see that kind of like duplicate away. But in our first number form, we don't have to fix it. Okay, so for the first number form, we just need to make sure no multi-values in one single record. Okay. Then when we move on, okay, so we need to design no partial functional dependency. If you remember, we have the functionality like dependence, right? So when we talk it, make sure every like non-key attribute, they must be like fully functionally like dependent on the entire key of that table. So when we learn it, so no partial, okay. Those are non-key attributes cannot like depends on only part of the key. So remember, so here's key points. So when we look at the second normal form, so it says person number, so it's like show primary key attributes, okay. And even later, like when you design or somehow, we always given a number instead of like the combination. So we need to check like every non-key attribute on the table, they're fully okay defined just by the salesperson. That means we can get salesperson name, yes. Commission, yes. Okay, year 5, department number, yes. Okay, or the manager, yes, they are all okay. So they are fully functional dependent. Okay, and also the product name, unit price. Okay, right here, and then the quantity should be to the salesperson and product number. Okay. So here will be the sales. So be careful. So kind of like similar logic, like apply to all the tables we're going to decide. So here is our second normal form. Okay, and after we define what's the functionality like dependence, then we can like break down to different tables. Okay, so this one is called the second normal form. Okay, so it's the okay. And then next we will doing is the third normal form. So it doesn't not allow transitive dependency in which, let's say, okay, one non-key attribute is functionally depends on others. So maybe you look at the definition, and then the non-key attribute, they're not allowed to define other non-key attribute. So it's the third normal form. Just telling right here. So let's say we say the salesperson name. Okay, can we like use the define others? Okay, let's say do we can like quantities? Okay, or the salesperson name like what's the manager or department product. So it's impossible. So we just make sure they're not allowed to define another one. Okay, and then also they not allowed like those like called a transitive like dependency. Okay, just make sure they are the full. Okay, so that's how we're going to design from the first normal form, second normal form, and third normal form. Okay, and right here, just remember like about the third normal form. So it should be like completely free of data redundancy. Okay, and also all the foreign key appears like where they need to be like logically tied together, related table. Just like make sure. Okay, so they should be um directly fully related. Okay, no transitive relationship. Okay, right here. And also it's the same structure that have been like driven from the proper I drawn ER diagrams of the same business environment. So you need to be careful. So here's really. And one thing about here, if we have the candidate keys, right? If you remember when we talk about the primary key, so it's like determines. Okay, so if there's one exception, like to the rule that like in third normal form, so non-key attributes are not allowed to define other non-key attributes, right? We say, okay, and the rule that does not hold if the like defining non-key attribute is the candidate key of the table. So it's okay. So those are candidate keys. So in a relationship, that means the table. So may define others like non-key attributes without violating the third normal form. So here's the tricky part right here. So just like give you the what's the functional dependency right here. So we show okay when you like sales number. So when we try to categorize it and upon so right here when we put in all those like fully functional dependence. So you see like sales number. We should put name, commission, year, file, department manager, right? How about the customer number? Customer name, okay, including the salesperson, then this will be the foreign key, okay, and then what's the headquarters city, okay, and maybe we have the sales, and then we have customer number, employee number, so we're adding the employee numbers right here, and then also maybe the customer and then employee number was the title, okay, so maybe right here. So when we go through all this, like we can check the functional dependency. And after we first time when we complete all this, then should be like let's say we have the first normal form and then put it like in all the each row and I have like only one value. Okay, make sure of it. And then we need to draw that like let's say when asked what's the functional dependencies, then you should able to customize all like put them all these to the dependency you need to draw arrow. Okay, so most of the time maybe from the primary key. Okay, when we pick the primary key. Okay. So right here, this situation maybe the publisher name, they are not duplicate. Okay, they all unique, then we can use it, but probably we will use the publisher ID. We always are using a number instead of a name. So will be important, will be better, okay, to doing this way. Or another one, the role music association, okay, or car rental. So you see, okay, when we join all this, then we can finish. And after we finish all the steps, then we need to check the data normalization, right? So the basic idea is you just check the structure, like the worthiness of the relation tables. So we need to like create through the layout diagrams conversion. So with the data normalization rules, is to check if they have any like partial functional dependence. Okay, do they have any partial dependency? Okay, also check there's any like transitive like dependency. Okay, so first normal form. Okay, make sure they have no duplicate or like multi-values in one cell, and then second normal form, make sure any like partial functional dependency, and then is there any like transitive like dependency. So after we create all this, then we can like doing it really practically, like how can we create the tables. Later in the lab, I would like you to doing the create tables. Okay, let's say if we need to create tables and then give them a tables name, and of course we will using the bracket to show it what is the attribute names. Okay, we need to define the metadata. So later we need to learn what's the those metadata, what's the type. Okay, we have a varchar char. Okay, and then we can define as a primary key. Okay, decimal. So what's the decimal or integer? Okay, string or date. Okay, and then if we want to drop it, so we can drop table. Okay, and then give a table name. Of course, right here, or later we'll learn how to create a view. Okay, we can save it when we need to extract some information and then we want to save it, then we can use a create view and then give a view name as, and then we can create using a select syntax. Okay, select from. Okay, if we need to drop the view, we can drop view and then the name. Okay, it's going to match, and of course we can update the table insert values. Okay, and then delete. Okay, I think in the lab, so you did have a practice, so you will be more familiar. Okay, so when you did some exercise on it, so update table name and then set which attributes, and then we always giving the condition. Okay, which column might match the condition. Okay, if we need to insert the a new record, so we insert into which table. If you just like putting the value in this way, you need to match the attribute sequence. Okay, so this one, let's say the numbers name like this. Okay, if you remember one of format, if I define what's the attribute sequence, then you can follow that sequence. Okay, and then of course we can delete from the records. Okay, delete tables, and then where was the condition. And so far here we covered the logical part of the our database, the logical design, including what's the normalization, right? So then you need to know what's the first normal form, second normal form, and third normal form. And so we talk about like we need to draw the diagrams, okay, of those like table of relationship, and also remember sometimes when I ask the functional dependence, okay, so how can you draw this one? So you need to pick up the attributes and then like categorize them together and then pointing to it. So it's a fully functional dependence. Okay, so you just need to remember. And so far that's it. Thank you.